Hello, my dear students. Welcome to my YouTube channel. So, as you could see here, this video is for the board exam 2021. Okay, so where you have got the timetable, I'm speaking about the Karnataka state syllabus. Okay, as of now, according to the timetable, you will be having an exam from May 24th. Okay, so now you people are in a lockdown, so you have got a much more time for the preparation. So I request you students, please don't waste time. Do more and more in practice, so that you can utilize the time and you can score a very good marks. So here I thought of doing the numericals, or the problems that are compulsory for your board exam. Okay, so there are four chapters from which the numericals will definitely appear. Okay, so since from 2014 till 2020, and even including the model question paper. So where the state board have given a two model question paper, I have included the numericals from that part also. And here let us go with a little information, then we'll start solving the numerical. See here, in your question paper, the numericals will be from the four chapters. Okay, so the first one is from the solid state. Okay, question number 27b, or sometimes for the part B 11th question also they may ask you from the solid state. Okay, so in most of the question paper, if you have gone through, the question will be from the question number 27b, where A will be packing efficiency derivation and B will be numerical, or else you may get the question in your part B 11th question. Okay, so this is for the solid state. So from here you could see you got 3 marks. Okay, if you are very perfect, if you practice the numericals from the solid state, definitely will going to get a 3 marks. And the second chapter is from the solution. Okay, so there is a compulsory numerical from the solution chapter for 3 marks, that too question number 28a. Okay, and then this will be based on a colligative property that we're going to discuss, no problem. Now the third will be from the electrochemistry. So from a electrochemistry based on the Nernst equation. Okay, so based on some Gibbs free standard Gibbs free energy, those all things you may get you definitely will get the question or numerical from this part, that is question number 29a. Okay, that's also for 3 marks. And the fourth one is like chemical kinetics, that is question number 30b. See, if you go through the question paper from the chemical kinetics, in some question paper, yes, the questions, the numerical been appeared. Okay, in some question paper it is not, but why to take a chance, you had to practice numerical from all the four chapters. Okay, so here you could see the total marks in your question paper from the numerical will be 12 marks. So dear students, the passing marks is 21. If you are very perfect with a numerical, here only you will going to get 12 marks. So while going to lose the chance over here. Okay, fine. Now in this video, I'll going to discuss about the solid state numerical. Okay, so solid state numerical, as I told, it will be from like what in your question paper from 27b. So in solid state, the numericals are very easy actually, because you had to learn only the one formula, compulsory one formula you had to, and other than that the three relation you had to remember. Okay, so most of if you gone through the question paper, all the numerical from all the question paper will be based on a density. Somewhere in 1 year they have asked you a question, they have asked a question from this one, that also I'll going to discuss. So this is a density related numerical, and the formula that you have to remember is D is equal to Zm by A cube into Na. So dear students, whenever you are solving the numerical, it is compulsory that you should know the formula and you should know what are all the terms involved over there. Okay, so D means density, Z means the rank of the unit cell or the number of atoms. Okay, so this you should know. I'm going to write for the FCC, the Z value is how much, dear students? 4. So for the BCC, the Z value is 2. Okay, and for the simple unit cell the z value is 1. Okay, so you had to remember, yes, you had to remember all these values. Okay, so z is rank of a unit cell or number of atoms. M is what, either molar mass of that particular element or the metal they have given, or it might be an atomic mass. A means what, a is edge length, dear students. A is edge length or side of a unit cell. So in your numerical they'll going to give you the edge length. Okay, what is a cube then? A cube is volume of the unit cell. Okay, don't get confused. So most of the students directly substitute the a value over here. No, a is the edge length. Okay, a cube is a volume of a unit cell. So in your formula you have a cube, not a. Okay, so now the last one Na is Avogadro number. It's a constant value, that is 6.022 into 10 power of 23. Okay, so this is a formula compulsory, you should know, you should learn. Okay, and next the relationship between edge length and the radius for FCC is a is equal to 2 root 2 r. For simple unit cell a is equal to 2 r. For the BCC a is equal to 4 r by root 3. These are the four formula you had to remember to solve the numerical. Okay, now let us go with, see here I have taken questions from 2014 to 20 including the model question paper. Okay, so I'll going to show you people one numerical how to do. Okay, so almost all the numericals are similar. Which are different I'll going to solve now. So which already they are similar in the same way how I'll going to solve this numerical, you had to go with that one. I have already done these numericals. Okay, thing is I'll going to put a PDF file of this one in my Telegram channel. You can take off this one. Okay, yes. Now let us go with the first numerical. First numerical that is asked in March 2020, 27th B question. So the question you just listen. Calcium metal crystallizes in FCC lattice with the edge length of 0.556 nanometer. Calculate the density of the metal. Okay, and further what they have given, dear students, atomic mass of calcium they have given and the Avogadro number is given. So dear students, whenever you are doing a numerical, it is compulsory that you have to understand the statement. What the statement they have given, if you get to know about that, then solving the numerical is very easy. For that you had to note down what are all the given points. Now see here, calcium metal crystallizes in FCC lattice. So when you hear that FCC lattice, so Z value is given, that is Z is equal to 4. How you got to know it's a 4? Because I have mentioned here it's a FCC. So you got Z value. And what they have given? They have given edge length A, that is 0.556 nanometer. Okay, now dear students, you had to do some conversion here. See, here the atomic mass of a calcium is in gram per mole. Okay, if it is in gram, you had to convert this edge length to the centimeter, because I'm going to keep the density in gram per cm cube. Why I need to keep in a gram? Because they have given atomic mass in a gram. So if it is in a gram, obviously it should be in a centimeter cube. Okay, you're not supposed to write it as a gram per meter cube. No. So for that reason, you had to convert this into what? Into a centimeter. So nano means what? I'll do step by step. 0.556 into 10 to the power of minus 9 meter. It is what? Nanometer. Nano means minus 9. Now if you want to convert into a centimeter, divide it by 10 to the power of minus 2, or 0.556 into 10 to the power of minus 9, or multiply it with the 10 to the power of 2. Okay, so then what happens, dear students? When the bases are same, powers can be added. So minus 9 plus 2, what happens? 0.556 into 10 to the power of minus 7. This is A, dear students. Okay, this is now in a centimeter. What do you need to find out? You need to find out a cube. One more point I'll going to add here. Just wait for a minute. So minus 7 whole cube. Okay, so this we're going to find out. Wait a minute. Now what else they have given? They have given atomic mass or the molar mass, that is 40 gram per mole. So what you need to find out, dear students, they are directly asking you that calculate the density of the metal. So density you have to find out. So by considering all these given points, obviously you have to use this formula. So I'll going to write the formula. D is equal to Zm by A cube into Na. Okay. See, most of the students, what they're going to do? Okay, I'll first substitute. Z is 4, M is 40, Na is 6.022 into 10 power of 23. Fine. Now, most of the students, what they're going to do? They'll take this AQ value over here and they're going to multiply, or they're going to find the AQ value here only. There where you're going to get confused. So instead of that one, why can't you find the AQ value here only and you can directly substitute here? So that will be the better way, right? So now see, I'm going to find out the AQ value. So in your theory exam, you can use the calculator, no problem. So now 0.556 into 0.556 into 0.556. So you got what? I'm going to write and then I'm going to shift the point. So I'm doing stepwise, dear students, so that you can understand. Okay, 79 into 10 to the power of 7 3s are minus 21. You can multiply here directly. Now rearrange the terms here, or you can substitute directly, no problem. What I'm going to do, I'm going to shift 1 2. So 17.187 into 10 to the power of minus 23, dear students. Why minus 23? I've shifted the decimal point forward. How many numbers forward? 1, 2. So if we shift the decimal point forward, the power will rise as a negative. So 10 power of minus 2, 10 power of minus 21. It will become minus 23. Now substitute this value directly. So you can avoid the confusion here. So 7 into 10 power of minus 23. Now the remaining step is simply a mathematical step. See what happens here. Minus 23 plus 23 will get cancelled, right? So 4 4s are 16, put 1 0. Now multiply these two numbers. I'm going to multiply. That is 17.187. If you want, you can do with me so that you can understand. Is 7 into 6.022. So what is the value got, dear students? 103.5. 0 0 is there, but I am keeping to the 5. Okay. Now divide these two. 160 divided by 103.5. So you got 1.545, dear students. What is it? It's a density. So what is the unit of density? Gram per cm cube. Why I am putting gram per cm cube, dear students? Because it is in gram. So I am taking it as a gram. So if it is in a gram, obviously it should be in a centimeter cube. So this is the answer for the question. Okay, so this is how you need to solve. Better you find out A cube here only. Observe the atomic mass what they have given. Okay, convert that into a centimeter and take a cube of this one. Simplify here only. Then substitute the value of A cube over here and find out. So this is the question of 2020. I hope it is clear. Okay, now March 2019. Okay, I have solved the the question here already. Okay, go with the same steps which I have done in the first numerical. If you get any doubt, you can comment and I'll going to solve it again. But already I have solved and I have given the answer. You just need to practice. So March 2019, they have asked in a part B, dear students. You have to concentrate on that. Okay. Now, July 2019, no numerical. July 2019 is a supplementary exam. So, no numerical been asked in July 2019 supplementary exam. Now, in case of a March 2018, again the same type of a question, same steps you had to do, and conversion into a gram and a centimeter, that all I have done. So, you had to concentrate on that one while practicing. Now, again July 2018 supplementary exam, they have not asked any numerical. So in March main exam 2017, similar type of a question been asked. I have solved that one. Okay, come to July 2017, again no numerical. And in case of a March 2016, again the same type of a question been asked. I have solved, and as I told, I'll going to give a PDF file of this one. Now July 2016, no numerical, and March 2015, actually no numerical been asked. That too, it's a main exam. There also they have not asked, dear students. And in July 2015, they have asked. Means you could make a difference here. If the question is not in a main exam, means numerical is not in a main exam, then supplementary definitely will going to have. But in most of the year, main exam will going to have a numerical. Keep that in mind. And in 27th B, it is same as that of March 2016. The answer is this much. I have solved it already. You can go through that one. Now, in case of a March 2014, it's a different type of a question. So that's why I'm going to solve you in front of you people. See here. It's like aluminum crystallizes in an FCC structure. Atomic radius of a metal is 125 picometer. Calculate the edge length of a unit cell of a metal. So dear students, here they have given you the atomic radius and they have told you to find out the edge length. Means they have told you to find out what A value. What they have given, dear students, they have given radius. How much? 125 picometer. Okay, and have mentioned it's an FCC. So here you should know the difference. No density need to find out, no atomic mass is given. Then which formula I will going to use, dear students? You have to find out A, and the R is given and they have mentioned it as a FCC. So I have given you the relation over here between A and R. In case of a FCC, it is A is equal to 2 root 2 R. Okay, so now do the same thing over here, that I am writing for FCC. A is equal to 2 root 2 R. This is a relation. So they have given radius 2 into root 2. What is radius? 125 picometer, means 10 to the power of minus 12. Okay, then multiply the values. So here root 2 means how much? Wait for a minute. So root 2 1.41. So 2 into 1.4142 into 125, dear students. So multiply all the three value over here. How much you will going to get? 2 into 125 into 1.4142. So it is 353.55 into 10 to the power of minus 12 meter, can be written as 353.55 picometer. Very simple. Okay. Yes. Similarly, these are two questions from the model question paper according to the reduced syllabus, dear students. So the question you could see here, an element having an atomic mass 60 U, that is unified mass, has FCC lattice. The edge length of the unit cell is 400 picometer. Calculate the density of the crystal. Okay, and now I am giving this as a homework for you students. You had to do. I am going to give you what are the given points. See here, an element having an atomic mass, that is M is given 60 U, and they are telling it as a FCC. So Z value is how much? Z value is 4. Edge length is how much, dear students? 400 picometer. Okay, and 400 into 10 to the power of minus 12 whole cube, that is A cube value. See, now here I am keeping in a meter. Why? Here they have mentioned it as a unified mass. They are not particularly given as a gram per mole. So you can keep the answer in kg per meter cube also. So that's why I'm taking it as a minus 12. If you want, you can convert. So even you can write it as a yeah, enough. This is enough, it seems. Okay, you can do this one. And what you need to find out, dear students, d value. So d is equal to zm by a cube into na. I hope you can do this one. Okay, and solve the problem and let me know the answer. Okay, now this is a quite different one. Metallic iron crystallizes in a particular type of a cubic unit cell. Okay, listen the question properly. Metallic iron crystallizes in a particular type of a cubic unit cell. They are not given whether it's a FCC, BCC or what. Okay, they are not given. The unit edge length is given, that is 287 picometer. Okay, and the density of the iron density is given, dear students. Okay, it's a quite a different one. So density is given 7.87. So I'm writing density is equal to 7.879, sorry, 87 gram per cm cube. What you need to find out, you had to find out the z value. Calculate the number of iron atoms per unit cell. Okay, you had to find out for a per unit cell what the number of iron atoms. Okay, so density is given, you need to find out the number of atoms, dear students. So here the formula d is equal to zm by a cube into na, and here you need to find out z value. So keep the z value there and transfer all the terms. So d into a cube into na divided by m. So what is density value, dear students? 7.87. What is a cube value? Here it is 2. I have done how, like I have shown how to do. So do follow this one. Into na is 6.022 into 10 power of 23 whole divided by what is m value? 56. Now sorry, plus 23 minus 23 will get cancelled. Okay, when you multiply all these value, you're going to get 111. Okay, you can do it later, and divided by 56. So it is, when you divide, you're going to get approximately 1.999, sorry, equal to 1.999, which is when we round off will give what? 2. Okay, now dear students, I got the z value 2. So I have given the value. If z value, number of atoms value is equal to 2 means which type of unit cell it is? It is BCC. Okay, so this is a different, same formula they are using, but in all the numerical you might have observed you have to find out the density, but here density is given, you need to find out the number of atoms. Okay, so this is how you need to do the numerical, dear students. Okay, I'll going to give this PDF file in my Telegram channel. Okay, you can go through that one. I have given you one numerical how to solve in the same way you try to do. Answer is there, but without saying you try to do. Okay, I hope you find this useful. In my next video, I'll going to solve numerical on the solution chapter. Okay, thank you so much.